Hello, my dear students, and the rest of the learners. Welcome to part 22 of a 95-part series of tutorials in object-oriented programming series in C++. In this tutorial, we are going to commence looking at how we implement objects and the classes in C++. And our focus will be on how to initialize objects and the classes. My name is MemJM, or you can simply call me MLSwap. According to the previous program that we covered at the part 20 of 95, under the topic on the explanation of objects and the classes, the initialization of student1 object, as well as the class, were initialized through the member function by the user being prompted to enter the value of the score and the grade. My dear students and the rest of the learners, for you to be able to understand what part 20 of this series was doing, kindly go to MLSwap ICT YouTube channel and listen to the video by the title Object-Oriented Programming in C++, Explanation of Objects and Classes, which is part 20 of the 95-part series. But of course, we are also going to see and work on initialization in this presentation. Initialization can also be done through the main program internally, as shown in the following program. In other words, we are saying that there are two ways or two methods that you can use to initialize the members of a class. One of them is by prompting the user to enter values into the members by passing through the object or the instance, as we learned in part 20 of this series. And the second way is to initialize those members internally within the program. In other words, initializing members internally does not give the user any opportunity to decide the values that each of the members is supposed to hold. Why? Because those values have already been preset by the programmer within the code. So in the following example, we are going to see how you can initialize the members of a class internally within the program. So we are going to make use of a program which we are going to call class object initialization. That's the name of my program. And then, of course, we have the pre-process directive iostream. We are using namespace standard. Then we define our class. So our class is called student. Note, this class is similar to the class that we defined in presentation part 20 of 95-part series. So we have members who are private, and these members are a score of type integer, grade of type character. We also have public members. Who are these public members? We have one public member called getData, who in this case is going to receive two parameters. One is of type integer, and the other is of type char. Kindly note that what we are doing here, this is purely prototyping. The definition of each of these methods will be outside this class or after main function. The second member, who is public, who can be accessed from outside this class, is showData. ShowData is a method which is not receiving any parameter and is not expected to return any value. That's why it is void. Then we add our and definition at that point. We have not yet defined an instance, or we have not yet declared an instance for this class. So this class will not be operational. It will not be active. It will not be useful till we declare an instance or an object for the class called a student. So we move on and have our first function, which is initializing score and grade through use of parameters. So our function is get data. Now, what does this statement mean? If you are told to explain what this statement means, you explain as follows. That this is a statement, is an heading of a function definition. The name of this function is get data. This get data function is a member of the class called student. That's why we have the scope resolution operator after the name student. So this function is not expected to return any value. That's why, or that's the meaning of the word void. So it's not expected to return any value to the caller, but it is expected to receive two parameters. These parameters are one, a, which is supposed to receive data of or hold data received of type integer, and b, which is supposed to hold data of type character. Then in the body of this function, we are initializing the score with the variable called a. So whatever that has been received as a parameter as a, that is what is being stored in the member called score. Then what has been received through the parameter called b is being assigned to a member of the class called student, who is grade. And that's the end of that function. Then we move to the main function. Under the main function, we first declare an instance or an object to be used to manipulate the members of the class called student. So this like setting the door. We are now setting the door, making the door ready to be able to access members of the class called the student. So what's the name of this instance? What's the name of this door? What's the name of this object? It is student one. So we are going to use student one to manipulate the members of the class called student. Then we declare and initialize a variable called value with an integer value, which is 90. We also declare and initialize a variable called performance with a character a. From there, we invoke the function. The compiler will invoke the function called getData. And in this statement, because this is a statement for calling or invoking the function called data, which is a member of the class called student, then we write it as follows. We include or we are passing two values. We are passing two arguments to the function called getData, which is a member of the class called student. So we write it as follows. Student one. In other words, we are accessing the member called getData through the object for that class called student one. So we have student one object. Then dot. We pass through student one to the function called getData. This function is expected to receive two parameters. So we are passing two parameters to the function called getData, which is a member of the class called student. Who are these parameters, or who are these arguments? We have value and we have performance. From there, we invoke the function called showData. It is accessible through the object called student1. So student1.show data, we invoke that function. Now, how does this program operate? Here's how it will operate. Once we invoke this function, what the compiler will do, it will go and look for the member called getData under the class. So it will move to the class and get and realize that the member is there. This function is called getData. So the two values that are being passed to it be received. So value and performance will be received as follows. Value will go to the parameter called int. Performance will be received by the parameter called car, or the placeholder called the car. Now that this is a prototype, the compiler will look for the function called getData. So already we can see that we have seen that 90 has been passed to this function. So 90 will be received under parameter A. So 90, which is in the memory location called A, or in the parameter called A, will be stored in the member underscore. The performance, which was A, will be received through parameter B. And therefore, A will be stored in the member called grade. Once that is done, the compiler will go back to the main function and invoke the next statement after the getData statement is done. So it will invoke showData. So the compiler will go and look for showData, which is accessible through the object called student1. So it will look for student1. It knows student1 is an object for the class called student. So it will go to the class called student. Here is the class called student. Then look for the member called showData. Here it is. It's not expected to receive to return any value. Neither is it receiving any value. But it's a member of the class called student. So it will then go to where that function is, because that's a prototype. Here is our function. And what will the function do? What will the compiler do? It will write out the message. The student score is, then look for the value stored in the member called the score, read it, write it out on the screen. Then display the next set of ones as, and his grade is, read the value stored in the member called grade, write it out on the screen. Then drop the line or write out a new blank line. In other words, the cursor will blink below this statement on the screen. And then the compiler will then go back to the main program and find that the next statement to be executed is the one which tells it to return the control back to the operating system because the program has come to an end, and end the program. Let's see how this program will behave. So the following is a demonstration on how this program behaves when compiled and executed in C++ programming language. In other words, my dear students and the rest of the learners, I would like you to copy this program. Write this program in your exercise book or type it in a word processor such as Microsoft Word. And then once you have checked that your program is okay, then you can copy it and paste it, or you can code it directly on your editor for your C++ program. So we are going to create a file under project called class object initialization. Then we are going to proceed. I'll copy and paste this program into it. And then we are going to see how the program will behave. So let's initiate our C++ program. So I'll start my C++ program. Here is my program. You can follow any other procedure to initiate C++ in your computer. Then I'll click on File, New Project. I'll click on Win32. Remember, this process is for those who are using C++ 2010 express. You can follow any other process using the C++ in your computer. What is more important is for you to have the editor for C++ program in which you can write the program. So the name of my program is class object initialization. Class object initialization. So type here class object initialization. Then I'll click OK. I'll proceed. Click empty project. Wait. Then I'll right click on source files, point on add, and click new item. I'm writing a C++ program, so I'll click on code, then C++ source files, and then I will have the name of my program as class object initialization. And then I'll click on add. So once you are on your editor, as you can see, once you are on your editor, you can copy your program. My program is here. I have already coded it in my 1D processor. So I'll just copy my program, which I've written in 1D processor, copy it. So that's my program. Copy this program, and then I'm going to paste it on my C++ editor. So if you have written yours in your exercise book, just type it statement by statement, word for word on your editor. If you have typed it in a 1D processor, you can copy your program and paste it on your editor for C++ as I have done. Remember, this environment is called Integrated Development Environment, IDE, Integrated Development Environment for our C++ program. I'll then save it by clicking on Save. Then let me compile my program. If you're using another version of C++ programming language, just look for compile. So I'll click on build, then build solution. The compiler is going to convert this program to object code if it finds out that there are no errors. As you can see, our compilation has been successful, none which has failed, none which is not up to date. So our program is okay. Then we can proceed and execute it. In C++ 2010 Express, we click on debug, then we click on start without debugging. And you can see, my dear students and the rest of the learners, if you compare this program with a similar program, which we demonstrated or we learned in part 20, where we are prompting the user to enter values, you can see that in this case, our output is just direct. We have not been prompted to enter anything. Why? Because already the values for the members were initialized internally. So you can see that we have a value for score and we have the grade. Those have just been picked from our program. You can see at this point, we declared variables. One called value, in which we stored into 890, and one called performance, into which we have stored into 8, letter A. And then you can see that we passed 90 as value and A as performance. So these were received by the function called get data as parameters. So you have seen that in this function received 90 and received A. It stored 90, it picked what was 90 and stored it underscore. And what was A, it has scored it in grade. So when we come to displaying the values, because show data is a member of the class that contains score and grade, it has just picked them directly as if score was a variable in the function called show data. So it has picked the value of score, and the value there is 90, and the value in the member called grade, which contains A. So what we are seeing outside, or when we execute our program, is this statement here, see out. The student score is 90 and his grade is A. And you can see the cursor is blinking below there, and we are being told to press any key to continue. And that's how we initialize the members of a class internally. So having learned that and having executed our program, then what else? It is important to note that if the score and the grade in the class were public, you would write a very simple program by just initializing them with the use of the dot operator as follows. So in other words, we can write our program, but in this case, we make score and grade be public members instead of being private. So our program is called class object initialization 1. Of course, we have our usual statements there. Now, under the class definition, under public, we now make score to be a public member. In the previous program that I've demonstrated, we had made it private. So this time, we are making it public. And also grade, we are making it public together with the member function called show data. So this, we have two data members and two method member, and one method member. We have two data members and one method member. The two data members are score and grade. The single method member is show data. And we add our definition there. Then we move to our main program. We declare the instance for our class by the name student1. Then look at how we are directly initializing the member of the class or the student directly. So this statement is initializing the member called score with the value 90. For you to directly access the member, we have to pass through the object followed by dot operator. So because we already created an object to be used to manipulate the members of the class called the student, and that object is called student1, if you want to access the member and do whatever you want to do with that member, we have to pass through the door. So pass through the object of that class, which is student1, by writing it, for example, as student1.score. Now, this is how you read this statement. It reads, pick value 90, store it in the member of the class which is accessible through the object called student1. So pick value 90, assign it to a member called score who is accessible through the object called student1. What does that mean? It means the compiler will pick value 90, then go to the class which is accessible through the object called student1, look for the member there called score, and assign that value into it. Similar to the next statement here, it simply means pick value A, then store it in the member called grade who is in the class that is accessible through the object called student1. So by so doing, those two statements are already initialized. The two data members of the class called student who is accessible through the object called student1. From there, we invoke the function. We invoke the function that is expected to display the values of the data members. How do we do that? This statement also says that look for the function called showData from the class which is accessible through the object called student1. Perform the activities in that or execute that function. Once that is done, the next statement will be invoked, which tells the compiler to return control back to the operating system and end the program. From there, we can define the method for showData. We have discussed about this method. This method remains just like we have seen in the previous example. This function is purely meant to display the contents of the data members who are a score and the grade. How will this program work? Let me indicate how the program works. Of course, we have the process directive there. We have the namespace, and I hope you remember what it is all about. We define our class. We make our members public, the data members score and grade and show data. Then in the main, we declare an object for the class called student. From there, once this statement is executed, just as I've said, the compiler will pick value 90, then pass through the object called student1 to go to the class for student1. Or that can be manipulated by the object called student1, and that is a student class. Look for the member called score and store in this score into this member value 90. Then go back to the caller, go back to the calling program, invoke the third statement, pick value A, then go to the class that is accessible through student1. And which class is that? It is student. So go and look for the class called student. Here it is. Look for the member called grade. Store that value into it. But is that really done directly as I'm putting it? Is that done directly as I'm putting it? For that to happen, just as you have seen, you must always ensure that you have, first of all, declared the class, then declared, that is defined a class, then defined, let me put it properly. Here, you are defining the class. You are defining the class. If you have a function that is a prototype, you define it. Then under main, you remember to create an object to be used to manipulate the class. Otherwise, the class will not be accessible, will not be usable without an instance for it. Then from there, you can be able to use dot operator to access or assign any value into the member of that class, any member of that class, whether it's a data member or a function member. You can see, like in this case, we are invoking showData function, but passing through student1 object. So once this statement is executed, or once this invoking statement or once this statement or this function is invoked or is called, the compiler will go and look for show data. And the class that is accessible through the object called student1, here is the member. But this is a prototype. So the compiler will look for the definition for that function. Here it is. So what will it do? It will execute a statement inside here, write or display on the screen, the student score is, in the value, in the member underscore, write it out, then display the next set of ones or string of ones and his grade is. Then access the member, called grade, read the value stored there, write it out, and then drop one line on the screen. And once that is done, then the compilation of that program, or once that is done, the program will have performed its purpose. And therefore, the control will be taken back to the operating system and the program will end. Let's see how this program will behave, or how it behaves when compiled and executed in C++ programming language. So just as we have done for the other program, I would just like to request you to copy this program as it is in your exercise book, or write it in your one processor program or one processor application, or using any other editor, including Notepad or Wordpad. Once you are done, you can then initiate or load your C++ program. Then on the editor, copy your program that you have written and paste it there. Save it, compile it, and execute it to see the output. So let's load our C++ program as usual. So I'm going to click there. I load my program. From there, I'll click on File, New. I want to begin a new project. Win32 console application. And the name of my program, I'm going to save it under this name. Class Object Initialization 1. Why? Because it's almost similar to the other one that we have already compiled and executed. So it is Class Object Initialization 1. Click OK. I'll proceed, and then I'll right-click on Source Files and New Item. I'm working, or I want to write a program, so I want to write a source code. So the name of my file will be Class Object Initialization 1. Remember, you are free to give your programs any other name, just as I've been saying under the C++ programming series of tutorials, as well as under the object-oriented programming series of tutorials. The only thing you need to always remember is to give your files or your programs names that can speak themselves. When you read the name of a file or a program, you can directly tell what that program is doing. So I have my program. I have my program in my editor or in my word processor. So let me just copy my program. If you don't have yours, just go through each of my statements on the screen in this presentation, and then just write them in your exercise book or type them directly on your C++ IDE or editor, or type them in a word processor. Copy your program and paste it on the editor for C++. So here is my program. I can see something else is opened here, and I should close it so that there is no conflict. When I'm compiling my program, I can also close that. It's always advisable that before you execute a new program in C++, you close the one which you've been working on before, so that there's no conflict when you are compiling, or so that you don't make unnecessary errors. Whenever you want to create or write a new program, ensure that you close the workspace for the previous. Close the previous file. Then have a clean slate in which you can create a new project, like for Visual C++ 2010, and also create a program. That is for beginners. As you advance in your programming, you can do anything else as you want. So here is our program. So I'll save my program, click on save. Then I'll compile my program. If it has any errors, the errors will be displayed. If it has no errors, we are going to see compilation successful. So our compilation has been successful, meaning that my program has no errors. Remember to always indent your program nicely. Always indent your program nicely to make it easy to read. As you can see, like you can indent these statements like that. This is just to make your program readable to you. Otherwise, the compiler does not care as long as your statements are okay. So as long as the syntax is okay, the semantics is okay, the logic is okay, the compiler will proceed, regardless of how the program is looking on the screen. But for the purpose of making it more user-friendly and readable, it's always good to indent it properly. So then you can click on Save. From there, I can rebuild it so that if there are any changes that have occurred, those changes can be reflected in my program. So the compilation has been successful. So I can proceed and execute my compiled program. You can see that the output for this program is just similar to the previous program. The only difference is that we have used now the dot operator. We have used the dot operator here instead of passing parameters. We have directly accessed the members of the class through the class object and assigned the values there. That's the only difference. Otherwise, the function for displaying the results is the same, as you can see. It's good for you, my dear students, and the rest of the learners to note. In this case, you have seen that we have done away with one of the methods. We don't have the method which we are calling get data, the one which we were using to prompt the user to enter a value, or even when you are passing the values. So here we have done away with that because we are directly assigning values into the data members of the class with the use of the dot operator. That is very key. So from there, we can press any key to continue. And with that, my dear students and the rest of the learners, we have learned how to initialize our members of the function or the members of the class, how to invoke the methods of the class, either internally or by prompting the user to enter the values. And with that, therefore, we have come to the end of part 22 of this series. You can continue to part 23 of the 95-part series of tutorials In object-oriented programming series using C++, in which we are going to look at how we implement objects and classes using what we call the free store. Congratulations for learning part 22 of 95 on initialization of objects and classes in object-oriented programming. You can access videos for the other parts in object-oriented programming series, as well as other computer or ICT videos by clicking or tapping on MLSwap ICT YouTube channel below this video. Remember to subscribe to the channel by tapping on subscribe button below this video in YouTube if it's not currently reading as subscribed. You can also join as a special member to enjoy special perks and make special requests for special topics or presentations by clicking on join button under this channel or below this video. For any further correspondence, kindly write to us through the email emilyswap@gmail.com. Thank you very much for listening to me. Let's meet in part 23 of this series, and God bless.